So do anyone have any questions regarding what we have covered in the class? So far, what we have covered. Does anyone have any questions? So we have covered functional testing, how to test an application, what to test an application, and I know if you have opened issues, if you have raised issues, we have also covered a test management tool that is Rally, to report, to report the defects, as well as to, create test cases and report the defects to the developer. Okay, so this class, we'll be working on various documents. Okay, so SharePoint. So let's see. Once I'll be working on this Jira, right? So once we work on this Jira, so I'll be giving you access to this Jira tool too. So with that, you can also use the Confluence. So it's called Confluence in Jira. So, it's a SharePoint. Okay, SharePoint. What is SharePoint? Anything which is it's a web-based tool normally. Okay, it's a web-based tool which you can add your documents. Various documents. Not generally test cases, but test plans, requirement documents, and so on. Okay, so that is for Confluence. So I'll be giving you homework on that. We'll just complete this, till Jira, so that we'll have some better idea on that. So, okay, so let's go to this documentation engineering. So we have this, lot of documents here. Okay, so although you will be going as the agile, so in agile, okay, they are little bit reducing the documents. They don't want documents. Okay, but it's not completely. They cannot completely remove all these documents. Okay, they will be having documents, of course, because especially in functional testing, right? You at least need to have some screenshot or at least some written explanation saying that, okay, so what this website is going to do, all those things. So you need to have these documents. So, why documents? Because some guy was working, he's working from 2 years and he left the company. All the coding, all this never shared to anyone. Nobody knows. Okay, so it has to be documented, right? Somebody has to prepare. Okay, this is how it will work. This is how the page navigates. All those things should be documented. Okay. If there is no documentation, then it's really hard for a new person. Forget about new person. Even the guy who is working from 15 to 20 years still is not able to find out issues in the application. Okay, in that case, the documents are very important. So okay, so let's go through one by one. So, we start with BRD. So what is BRD? It's a business requirement document. So what does it contains? So business requirement documents contains use cases. Okay, use cases, budget information. Okay, it also contains the project information. Okay, it's pretty much high level. It's a high level document. So what is business required document? It's a high level document prepared by whom? Prepared by business analyst. Okay, the business analyst are product owner. Okay, in agile you call is product owner. Okay, in waterfall you call is business analyst. Okay, that guy actually prepares this BRD. Let's quickly check how does that BRD looks like. Okay, so I'll be giving you access of this Google Drive by today. Oops, I should have prepared that. Okay, so I'll give you access of this Google Drive by today. You can go ahead and view those documents. So here I have all these documents. Okay, you can refer to this. Go to testing documents. That is directory number 4. And go to business documents. Okay, so let's quickly check how does it. Okay, you go to MasterCard BRD. So here, this is how business requirement document looks like. Okay, so this, so this is a document. Okay, so it contains a lot of information here. Okay, so it shows like what is a project, what we are trying to do, and what is business, what you're trying to here, and what is the requirement, what is the project requirement, and this is the business requirement. So it's not necessary for a QA or for a software tester or a QA analyst to understand everything at once. Okay, as a QA point of view, as a software tester point of view, you need to see what is required for your testing. Not all is required. Okay, I don't know what is going on in a lot of things, because this document is prepared keeping in a lot of people in mind. Okay, so because Scrum Master has its own job and responsibilities, he has to look through this document. Developer has to look through this document, and they have their own responsibilities. Architect guy has to. So a lot of people are involved here. So it's not just like, okay, I'll read this and I know everything. It doesn't work that way, because this is prepared by keeping in so many people in mind, and this pretty broad level, and not everyone understands everything at once. Okay, so we need to skim the information what is required for our testing perspective. Okay, so that's just like this. You see this just like requirements. See, like, let's go to the business requirement. Here you have the 3 blocks, right? You need to see here. Look, what kind of test cases you need to write based on this. What we need to work on this. So you need to see this information. Not everything. You have a lot of things. You have 20, 30 pages. Okay, we may not require, as a QA point of view, we may not require all this. Okay, so you need to read this whole document and understand what is required as a testing perspective. Not everything. So we don't worry about everything and what we need to do. Yes, you need to read this once, so we need to make sure what we are going to do and what's the project all about. Otherwise, mostly you will be writing test cases based on these documents, not by just, as I showed you, ready-made application. Doesn't work that way. Not always. Since we had ready-made application, so we wrote test cases based on that. But in real time, don't expect such an easy life. Okay, it's not easy. You will be having this kind of documents, and you look into this document, go through this document, understand what is written, and based on that, you need to write the test cases. Okay, so it's you may not always have application ready-made. Okay, so that's how the business required document. Okay, so what is business required document? It's an high-level document. Okay, it's a high-level document which contains information about the project. What's the project about, and what's the use cases. Budget information. All this information is there in the BRD, business requirement document. Okay, then we have functional requirement document. Okay, so this is FRD. So what's a big deal in this FRD and BRD, right? Both are similar. Both are requirement document. Here, this is a little bit more specifically defined here. Okay, functional. That means it contains the applications features. A lot of application features and a lot of functionality. So that's why it's called a functional requirement document. Okay, BRD don't have to be always FRD. Okay, because it's not necessary it contains. So we didn't see any functionality feature, right, in BRD. So this may not always contain functional features. But this is it's a high-level document which contains information about functionality and features of an application. So what is FRD? Functional requirement document contains functionality and features of an application. So let's go through this. Let's take an example here. Okay? Let me show you a pretty quick, simple application. Okay, FRD application. So this is this is the document it contains. Okay, the guy who is responsible for reviewing and who is responsible for validation. Okay, and who is supposed to approve it. And this is the requirement. So we have the functional requirement. So let's go through this pretty quick. This is the functional requirement. So this, you need to go through this and then to understand this. Okay, based on this, you need to write the test cases. Okay, based on this. So let's understand what he's trying to say here. Okay, here it says like prescriber first name. Okay, so that means it contains first name field. So that's what it's trying to say. First name static. First name is static and contains for first name field value. Okay, let us compare with what application we have. It's not for this. This is not for this application, but we are trying to compare it. If it is that, how does it looks like? Okay, so here is the thing. So it contains first name. Okay, so our application also contains the name. That's good. It has last name. Okay, we don't have last name, so you need to include here too. And you have this address value, right? So we do have this address. Address static text, that is address, and the field value is the field value. So that's what it's trying to say here. Okay, address is what's the static text and what's the field value it contains. The similar way, all these fields. Okay, the similar way, if you want to compare this, we have all these fields what is shown here. Okay, so again, this is not an FRD for this application. There is no FRD for this application. This is a completely different FRD. Okay, that doesn't have this application. So don't just think that okay, this is FRD for this application. No, this is not. This is a different application. We are trying to compare. Okay, so how if there is a functional requirement document, how can we relate to that what we have it? Okay, so that's what it's used to compare them. Okay, and so this is related to for more design perspective. What SQL query they need to design. It's for the developer point of view actually. Okay, so this is a developer point of view. So what they have to do. Okay, so this is pretty simple FRD. Let's check. So there are other requirement documents. Just you can go ahead and view this requirement document. Okay, so there are corrections. Somebody has validated it and they want to correct this document. All these things have been done. Okay, so this is how requirement documents look like. Okay, let's go to the next topic. System requirement specification. So this what is system requirement specification? So it contains all the information of the system. Like what? Like hardware features or software features. What are the applications we will be using it? Okay, so all those things is like system requirement specification. Let's quickly check how we have this for an application. We have. So this is what it contains. You need to understand this. Okay, so what is the purpose of this document? What is the product features it has to contain, and what is the operating environment. Okay, so all this we will not be viewing all this as a QA, but to have some knowledge on this, you need to at least look into this, because sometimes you might raise an issue, right? Sometimes when you raise an issue, you don't find your answers in any documents. Okay, you don't have any documents, and lead doesn't respond to you. Okay, they don't care. Whatever you do, they're not bothered. So in that case, you need to understand this system required specification, so you can understand that is it a real issue or not. Okay, so that's the reason you need this document system specification. System requirement specification document. Okay, so you need to understand how this is designed. Okay, what are the software we'll be using, what is the hardware features and what is the software features, what are the applications which is related to it. So all these things will be you see this, you'll be doing all this. Okay, and what are the non-functional requirements? Okay, even there are functional, this non-functional, what are the safety requirements? So all these things will be there in the system requirement specification. Okay, so what is SRS? SRS is a high-level document. Okay, SRS is a high-level document, and what does it contains? It contains information about the system-related information, such as what is the software we'll be using it, what are the hardware we'll be using it, what are the non-functional requirements we'll be having it, what are the functional requirements, and so on. Okay, So that is about system requirements of specification. And next we have PDM. PDM is physical data modeling. So let's quickly check again. So in PDM, right? So let's quickly check how does the PDM looks like. So this contains information about the so physical data model. What are the physical tables? What is the table structure? Okay, how the table is designed? So it's more like an ETL point of view. Okay, so here is so this is this is how it looks like. Okay, so these are the let's say you have this table and how the table is designed. So it's like related to more of a table information. How many tables? How many tables does it contain? How many columns it has? How many rows it will be there? So all this. Okay, so let's quickly check and so okay. So here you see this. So this is not really a PM. This is more of a ER diagram. So entity relationship diagram. So this is very important when you are testing and ETL testing, because you want to know, because you're querying a stuff. You're querying source query. You will be using source database. You will be using target database. You will be using staging database and so on. When you're using that, first thing to keep in mind is what kind of keys you are using. So you need to use primary key, foreign key, candidate key, natural key, and so on. Okay, so all those things, whatever you are using, so this will be shown in ER diagram. Okay, entity relationship diagram. If you don't have this, you need to request this, because without this, you technically testing is not done. Okay. I mean, if you don't have ER diagram, that means you're doing wrong. Okay, you need to have this. So nobody will give you this. Okay, when you're doing this, nobody will be giving you. You need to ask. If you're not asking, that means you're not doing. That's it. Okay, you need to ask where is ER diagram. It should be in Drive. Sometimes it's SharePoint. Most of the time it will be in SharePoint. Most of the time it will be not there. You need to check. Okay. So this is all contains in PDF. Okay. So entity relationship diagram is completely different. It's it's integrated into this because to show the relationship between the between the tables. Okay. So otherwise, ER diagram is completely different thing, and it is normally prepared by database administrators or database to make sure how the structure is designed, how the database features So all those things. So that's PDM. Then you also have one more like LDMs, that's like logical data modeling. So here instead of tables, so this is more for a views. So view is a views also is there, right? So it's a so that's because it's a logical entity, right? So that's information is contained in this logical data model. Okay. So this is how the documents look like. Okay, so let's move to the next one. So next we'll go through HLD. So this is high level design. So let's quickly check what is a high level design document. So this is more related to call flows. Okay. Do we have this? I don't think I have this. Okay, so I don't have this HLD document, but this is related to more of a call flows. What is a call flow? It's a flow chart. It's a flow chart kind of. Let's take an example. Okay, so how, what is this design? So it contains all the diagrams. Okay, so it's contains the diagrams, entity diagrams. Okay, okay. Let's say, for here, let's take an example. Okay, if you are, there is, one thing called IVR, okay, interactive voice response. Okay, so IVR, right? So whenever you call customer service, or whenever some bank, or they have this IVR. Instead of directly giving directly to the customer care, a real person, they just go through this web services. Okay, so this, when you go through IVR, so they ask you a lot of information. Okay, so what is your first name? What is your SSN? Okay, so on. So in that case, you give some information. Okay, that redirects to another flow. Okay, once you enter that flow, again there are numbers, right? Press 1 to continue, press 2 to technical issues, press 3 to new user, press 4 for so on. So those flows, right? Those flows are made into diagrams. Okay, so diagrams, like, that's called call flows. Okay, flows. It's a flow chart. Okay, flow chart, right? From when you start, if you press number 1, where does the flow chart goes? If you press number 2, where does the flow chart goes? You press number 3, so on. Okay, so that all is summed up in diagrams and showing the relation between these, whatever you're trying to say, and where the flow is going. So that's called HLD design. Okay, high level design. Okay, so another, you have this PDD. This is technical design documents. In this technical design document, what you normally have is this. Let's say you're doing, okay, you're working on ETL project and you have this jobs. Okay, so job, what is the job? So whenever you, again, like, let's go back. So as we have discussed, we have 3 environments, right? Dev environment, test environment, and production environment. So now, to pull all the code from the dev environment to test environment, it's not easy. You can just just type some, put some buttons and say that, okay, it's done. No, that doesn't work, especially when you're working on ETL, because in ETL, there's a lot of information. There's customers' data. Okay, so this data is on TBs of information. Okay, a lot of TBs of information. A lot of people apply, and a lot of things happen. Okay, so there is plenty of data. Okay, TB of data. Now, to put that GBs and TBs of data from one environment to another environment is not easy. You cannot just say, okay, I'll just copy and paste. No, it doesn't work. So what you need is some kind of tool to move that code, not just code, including the code, you have data. Including code and data, you need to move into one environment to another environment. Okay, what you use is a kind of tool called job scheduling tool. Okay, because you need to schedule a job, you need to move that code from one point to another point, one environment to another environment, right? So that you use this tool, job scheduling tool. There are so many job scheduling tools. There's Autosys. Informatica has its own way of doing that. They have, it is integrated. Informatica has its own scheduling tool. You can monitor jobs. You can, run the jobs. So all this, is put in TDD, technical design document. So what it contains, it's kind of called those two. This kind. So you run this job. What is the next job? Okay. So once independent jobs are clicked, next you need to click, once independent jobs are done, then you need to go with the dependent jobs. So what are the dependent jobs? Once you hit the dependent job, okay, how does that, what are the dependencies on that? Okay, dependent job has this dependency. So all those things are put into, this is also a flow diagram. Okay, this is also like flow chart. Okay, but here you're talking about more the ETL point of view, and HLD is more for a it's kind of web services, so you can say it's functional point of view. Okay, so TDD is technical design document. It contains information of job scheduling tool. Okay, so what are the dependency jobs? What are the which jobs should be kicked first? Which is the dependency jobs? So on. Okay. Okay, so let's move to the next one, STM. Okay, let's close this. So STM, so let's we are running out of time. So STM is source to target mapping. Okay, so let's quickly check how does that looks like. So what is, oops, we have this. So can anyone say what is mapping document? Does anyone know what's exactly a mapping document? Okay, so now let's quickly check this. So STM is source to target mapping. So so why is this? What is this? It is a mapping document to make sure to write your test cases. You need this when you're using an ETL. You need this mapping document. Technically may not require any FRD, BRT or anything, but this is a must because when you're writing test cases, this should be there. Okay, so this is not like front end, like this is a back end process. So what is mapping document? It contains all the information about the source and the target. So that's the mapping document. Why do we require that? We require to understand the features of the database functionalities. Let's quickly check. Yeah. Here you go. So this is what it contains. What does it contain? So what does mapping document contain? It contains information about the source and as well as the target. Okay, even staging. If it is staging, staging. Again, the source has its own table. The target has its own table. Okay, source has its tables. Again, it has columns. It has rows. It has keys. A lot of things are happening here. So let's go one by one. So here you have BDW. So what is BDW? Business Data Warehouse. Okay, there's also EDW, so Enterprise Data Warehouse. Okay. Okay. So here, you have this column name. So this contains all the information. So let's say we are talking about this column. Table, target table. Okay. What does the target table contains? It contains columns and rows. So here's this. Is column name. These are all the columns in the target database. Okay. Now you have this BDW target column data type. We have data type. Is it an integer? Is it a varchar, variable character? Is it a date format? So on. BDW target PK. PK is primary key. Okay, is the primary key. So you normally have one primary key for one table. Here you have this more than one. So it will be considered as composite primary key. Okay, so this composite primary key can contain up to 24 columns. So we don't require that complex database. So let's not worry about it. Then you have this reference code. Okay, reference table name. This is kind of this is reference. So you want to refer to another table because some values are stored in the reference table. So you want to make use of this when you're writing a SQL query. Okay, and then so this is all about target. Now let's talk about the source. Okay, source field name, source field type. Here is the thing. Mapping. This is business logic. So based on this information, you need to write your SQL query. Normally, the mapping is done at the target point of view. So because source is a production data. Normally, it's not production environment. We are talking about production data. That means that production data is actually refreshed to this environment. Okay, so that's why it's more of a, it contains mostly, with SSN hidden and all those things, it contains information about production data. And yeah, so that's the reason, right? So normally you don't write the business rule to source. You write to the target once, normally not even to the target staging. So, but there are instances where you need to write for source too. Okay, so here we are writing this mapping for the source. Look at this. Source should be your mapping rule. Sometimes you have target to mapping rule. Okay, so make sure where you are actually writing this business logic. Okay, so and you have this other information. So this is the what is this? This is called STM, source to target mapping document. Okay, so it contains all the information about the source column, source table, source rows, source keys, and also contains all the information about the target column, target rows, target keys, and so on. It may also contain the staging information too. Okay, and also reference tables. Okay, so on. So a lot of information is there too, and this is enough to write your test cases. For writing test cases, this is good. Right? Source query, target query. Okay, you will be good. Okay, so that is STM. Let's go to the next topic. Oops, we'll just complete this quickly. So test plan. So test plan. So what is a test plan? Test plan is a high-level document and prepared by the QA lead. So this document is prepared by the QA lead. And what does it contains? So it contains information about the project. Okay. Okay. So this is what it contains. It contains like various issues. What are the risks we are taking? Okay. What are the items that are to be tested and not to be tested? Okay. Test pass fail criteria. Okay. And what are the test deliverables? Okay. All these things it contains. So what type of testing we are doing? We are doing functional testing. We are doing load testing. We are doing performance testing, regression testing, so on. So all these are in the test plan. So what is the test plan? Test plan is a high-level document which is prepared by the QA lead. So just because QA lead is preparing doesn't mean that you will be sitting idle. You will be giving inputs. Okay. So because something which is not there in this plan, so you will be saying, okay, why don't we include this risk? I've prepared this risk. So why don't we include this risk? And who will be testing this? Who is responsible for this? Who is and what are the contingency with this? Okay, what are the test deliverables? So on. So all this information is contained in the test plan. Okay, so let's move to the next one. Test strategy document. So what is the test strategy documents? So it is similar to test plan, it's not same. So it contains all the information which is not there in the test plan. Okay. So some, most of some companies, they, for test strategy, test plan, they say it's same. So go with the flow, don't argue, no, this plan is different, the strategy is different, okay? Okay, so always, you can go with the flow. If they are saying the strategy for test plan for test strategy, okay, go with the flow, but technically it's not same because the test plan, is more related to how we are planning. Strategy is something which is approach, how we are trying to approach that. Okay, so the headings and all this will be different from test plan. So here you have this test items, features what to be tested, features not to be tested, and what are the testing tasks and environmental infrastructure needs, and who is responsible for this, how many testers are required. So all these things are there in the test strategy document. Okay, so you can go ahead and read this document. And test cases. So what is a test case? So we know test case, right? Test case is a high-level document, okay, prepared by the QA analyst, okay. Test cases is the high-level document prepared by the Q&A list. What does it contain? It contains information about, okay, it contains steps, okay, expected result, actual result, okay, pass fail criteria, okay, pass fail, okay, and comments, okay. So all that it contains in the test cases. Okay, so let's move to the next topic pretty quick. So we have this migration document. So what is a migration document? So let's say, let's say you are working on some migration project. Okay, some migration projects. So let's say, the source is, okay, the source is DB2 or DB2. And there's a lot of source coming on DB2, Teradata, and so on. Okay, now you're migrating all those into what? Oracle. Okay, now you need some documents to refer it because Teradata, the queries are different, the way they write the query is different, the way it is stored in the database is completely different. Okay, and Oracle SQL queries are different. Those SQL queries don't match. You cannot just write SQL queries, what you have written for Oracle, what you are writing for Teradata. So you need a migration document. So make sure, so to making sure, okay, so what are the database we'll be using it? How are we going to migrate the data from, from a different database environment to another database environment? What are the various databases we'll be using? What are the various files you'll be using? All that information will be there in the migration document. Okay, so that's why we need this migration document. Okay, any questions so far? Okay, there are no questions. Let's move to the next topic. So, we'll just go through the next topic, which is SDLC, software lifecycle, software development lifecycle. Okay. So we have completed all the documents, various documents what we need in the project. Here, what we are discussing about this SDLC. Why do we need this? Because we need it because you're working on environment where there's a lot of people working on. Okay, so you are not the one who will be deciding what processing. It's a work framework. Okay, so this is not a tool. So SDLC is not a tool. SDLC is not an application. No, give me access to the application. I'm looking at it. No, that doesn't work that way. Okay, SDLC is a framework. Okay, it's a framework. It's kind of environment where you are, you need to work. Although this is designed by the, all this is taken care by the management perspective. We are not, have any relation with this SDLC or something. Whatever they say, we do it. But you need to know this because if there is an improvement or you need to know how the process works, how the system works, all those things you need to know. This is a framework. It's kind of framework that means the kind of environment we are where you will be involved in working on this. Okay, so let's go just quickly. So all these slides are there in Google Drive. You can have it a look. Move on. Okay, so let's go. So waterfall. So all these methodologies, what we will be discussing, is derived from SDLC, Software Development Lifecycle. Okay, so we'll go one by one these methodologies. The first thing is waterfall methodology. So let's quickly check. So there is, there is like 10 phases. Okay, 10 phases in SDLC. Okay. If you have time and if you if you think you're good, go ahead and refer this. You can remember all this 10 phases. If not, I'll stick to only 6 phases here. Okay, so we'll stick only to 6 phases. Okay. So why it is called waterfall model? Because it's one way, no two way, one way. That means it is from top to bottom. Then you cannot go. Okay, if you find some issue in between, nothing to do it. You need to go in from scratch, from top to bottom. That's it. There's no other way. Okay, that's why it's called waterfall, because the water flows only one way, right? From top to bottom. So same way they have designed this waterfall methodology. So that's the reason it's called waterfall methodology. So here, let's go through each phase. So there's a requirement phase. So what happens in this requirement phase? So there are 6 phases: requirements, design, implementation, testing, installation, and maintenance. Okay, 6 phases. So let's go one by one. So what is the requirement phase, and what happens in this exactly? So in this requirement phase, what happens, right? Business analyst, a product owner, prepares all the documents, gathers all the information. Okay, from the business, they talk to business, they talk to developer, they talk to tester, and scrum master, and so on, and gathers all the information what is required for our testing perspective, what is for developing or for testing, all those things, and they put it in one document, and it's their job. It's normally it's business analyst job to do all this work. Okay, to gather all the information to get ready for development. Okay, then design document. So what happens in the design is like so this is more of an architect level job. So how the structure, how the table structure should be, how the application structure should be, how the application should look like, how to look at the application. So all this architecture guy, the architect guy will be designing all this, and they will be working on this. So that's the job of designing. Okay, job of an architect. Implementation phase. In the implementation phase, developer, here is the way the developer codes. Okay, he codes, all the coding work is done in this implementation phase, and all this is taken care in the implementation phase. Okay, testing phase. So this next the test. Here, what we'll be doing here in the testing phase, we'll be testing all this, and we'll be working on this. So this is in test. Okay. And then installation. So installation is more for a middleware team who will be working. You need to be coordinating with the middleware to move that code from one environment to another environment. Okay, that's the installation phase. Maintenance. So if let's say if you have any production issues or anything which is not good, which is not looking good, you need to do maintenance there. So here the senior QA, senior developer, all those people will be there in the maintenance. Not any new hire people normally won't be there in the maintenance phase. Okay, so this is mostly done by the developers and senior testers. Okay, so let me ask you a question. As a tester, as a QA tester, which phase will my work start from? So as a QA tester, which phase does my work start from? Can anyone answer? Okay, so somebody, some people told like our job starts from okay, so many people, so many answers. Okay, so everyone answer is completely different to each other. Okay, so Yeah, somebody answered it as a requirement phase. Can you tell me why our job starts from requirement? What's the basic criteria of starting of our job from the requirement? Okay, so as a QA tester, as a QA, our job starts from right from requirements. Okay, so let me ask you a question. So if somebody told like testing, so what do we think? If you are being start your job from testing phase, so all these phases, will be idle. So you will be doing nothing. And do you think somebody, does anyone pay you for being idle? So if our job starts from test, okay, so we have three more phases before that. So do you think we'll be idle, sitting here and doing nothing, and you will get paid for doing nothing? No, right? You will not get paid for doing nothing. So that's the reason our job starts right from the requirements. So what exactly we do in the requirement. So in this requirement phase, right? So we need to, we work with business analysts, product owners, and that okay, these are the documents. Okay, these are the documents we'll be looking at, and what are the issues we will be facing it. What are the risks we will be working on. Let's say there is a lot of too many environments, right? QA1, QA environment 2, QA environment 3, QA environment 4, so on. So now we will be talking to which environment we'll be working on, which environment this code goes to. And if it, let's say they will be saying some answer, and we need to say like, okay, we have a lot of environments blocked and we cannot move in this. There's already regression testing is going on, but a lot of things will be happening. Okay, so that all happens in the requirement. So here you will be brainstorming. Okay, brainstorming. What are the issues we will be facing it? What are the actual requirements we are working on? Okay, how we are supposed to proceed with testing based on this requirement. So all those things, a lot of things. You need to have a meeting with them and get your questions answered on this requirement, because you may also have issues in the documents. Okay, you might have issues. Okay, as a tester, I also need to raise an issue on the document. So this document doesn't look right. Okay, this is this is not the application. This is what we have tested already. Okay, so this is already gone into production. This is no way feature. This feature we are not working on. Okay, so all those things are discussed in the requirement. Okay, so as a tester, as a QA, we'll be starting from the requirement phase. In the design phase, let's go to the next design phase. In this phase, what we are going to do is we'll be writing our test plan document, test strategy document, test cases. All those things we'll be doing in the design phase, right? Okay, so let's move to the next implementation phase. So what are you going to do in the implementation phase? Okay, let's say we didn't have enough time in putting in test. We only design test plan document, test strategy document. We need to work on test cases. So we'll be doing in the implementation phase. We will be working on an implementation phase. Okay, so and then in the test phase, we will be actually testing an application. Okay, this is where all the test cases are ready, all those things are ready. You'll be working only on execution part, and you'll be running that all those test cases, whatever you have written, you'll be executing all this in the test phase. In the installation phase, you will be coordinating with this team, middleware team, okay, or whoever is responsible for this, will be working on and make sure that code is moved to this environment is working right. Okay. In the maintenance phase, of course, in this phase, a senior QA, senior guy will be working on this to make sure there are no production issues. Even if there are, so how you need to fix it, how we are going to move quickly, all those things will be discussed in the maintenance phase. Okay, so we are not idle. So we are not idle from first phase. We'll be working on requirements. That's brainstorming, brainstorming and issues in the documents, issues in the environment, issues in the in a lot of things. If there are any, not necessarily they have to be. If there are any, we need to discuss. Get your questions answered. All this in the requirement phase. In the design phase, you'll be writing your test plans, test cases, implementation. You'll be working on test cases. Okay. And the testing, where you will start testing. Okay, so this is the 6 phases in waterfall. Any questions in SDLC? So this is this is derived from SDLC, not exactly this is the SDLC. So this is a waterfall model. So this is a model, the waterfall model. So here, why do we use this waterfall? The biggest advantage what I see here is where you want quality is more important than cost. When you are looking at the quality, you need a quality in your work. So that's why you use this waterfall. Agile, so agile is completely the other way around, where cost is more important than quality. Okay. So that's the reason we want to prefer waterfall. So that's the most important advantage of this. Okay, so these are you can go through this, and this is there in a Google Drive. Let's quickly check. Let's move to the next one. Let's quickly show you where exactly these slides are. So I'll be giving you access of this Google Drive by end of today, and you can view this here. Okay, go to 26th drive. Here you have all this information. What I know, you have the slides, you have SDLC, a lot of information here. So you can go ahead and you can view this. Okay, so let's move to the next topic. That is V-shaped SDLC model. So this is also derived from SDLC. Okay, software development lifecycle, and why it's called V-shaped? The similar features we are using here: requirements, analysis, design, unit testing, coding, same thing we are using. Okay, but here you are doing simultaneously 2 things at once. You see this production maintenance, you're doing requirements planning, again you're doing requirements, again your acceptance testing. So that's the reason it's called V-shaped SDLC model, because parallelly you're doing 2 things at once. Okay, and so it's like similar to waterfall, but waterfall we are going one by one, so one after the other. Here you are doing 2 things at once, so that's why it's called V-shaped SDLC. So it has its own advantages and disadvantages. So you can go through this. So there is one more called incremental SDLC model. So this is incremental. So this we have seen SDLC, right? So we have this similar feature. Here is incremental. That means we are doing like both verification and validation. So here we are doing both things, verification and validation. Okay, not even this. You have this like detailed design, code, implementation, and after verification, you want to verify it. Okay. And product design, how the product design is done, how the system feasibility is done. So that's called incremental SDLC. Okay, it has its own advantages and disadvantages. Okay. Next one we have. Okay, next we have spiral SDLC model. Okay, so this is like differently, put together. This is we have like 4 quadrants. Quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And each quadrant, you are performing some, feature like, here you are doing like, you want to determine objectives. Next, after moving, you move to the next quadrant, evaluate the alternatives, and, next develop that, and next plan. So all things will be doing the same process. That is requirements, design, implementation, prototype design, and so on. It will be moving like spirally. So that's why it's called spiral SDLC model. Okay, so that, that's one more like spiral SDLC model. And does anyone have issues? I'll take like 5 to 10 minutes. We'll complete this. Okay. So if anyone has issues, let me know. Okay. So we'll just complete this pretty quick, and tomorrow we'll go to Agile. So I'll be taking a detail one class for Agile. So we'll just complete all these methodologies today. Okay. So it has its own features and all its own pages. Okay. Here, let's move to the next one. Agile, we'll go. Agile is a little bit different than SDLC. Okay, it's it has so many other. So Agile is pretty big now. It's a high level. So what is an Agile? Agile is an iterative and incremental process. So Agile is an iterative and incremental process, and we have a lot of features in this. We have extreme programming. You see this extreme programming. We have like Scrum. Scrum is more famous. Scrum. Then you have Kanban. Okay, there's also Kanban. Then adaptive software development. So these are all like sub stages of Agile. Okay, if you want to do, you can do all this, but all this is not required. People stick only for one, as a Scrum or Kanban or extreme programming. Okay, only one thing. So we don't do everything in just one. Okay, so that's about the Agile. So this is information about why do we need this extreme programming. Okay, so let's move to the next one. Okay, any questions so far in SDLC? So SDLC, we have different phases. So we discussed about waterfall. We discussed about V-shaped model and incremental SDLC. Then we also talked about spiral SDLC, then agile. Okay, so these are like major SDLCs models. Okay, these are models. So how do you want to implement is based on this management perspective. We are not going to implement this. This is a management work. It's their job. We are not to okay, I want agile, I want waterfall. No, that is not we decide. It's decided by management, and based on that you need to work on that. Okay. Okay, so let's move to the next one, STLC. We'll go pretty much quickly go on this. So what is STLC? So like SDLC, right? SDLC is software development lifecycle. So the similar way you have software testing lifecycle. So SDLC is everyone has to know. SDLC is like it's common. Even developers has to know. Even testers have to know. Okay, even everyone has to know. But STLC is something like not everyone has to know. This is a process. Again, we are discussing about the process. Process is a framework how you need to work. Okay, so that's a framework. Okay, so STLC again, it is not if you go and ask for a developer what is STLC, he will not tell you. No, even if he knows it, he will not tell you what is STLC. It's not his job, right? You need you have to know it and lead. So this is how the hierarchy works. Okay, so this is how this is. So tester, lead, QA lead, okay, QA analyst, QA lead, QA manager, QA director. So this is the hierarchy. So all this only will be knowing how the STLC works, not developer. Okay, don't ask me a developer what is STLC. Okay, so here, so there are phases, just like we had phases for SDLC. Okay, what you have is test plan preparation. So we know we have gone through this test plan. So all this we'll be preparing. Then you have this test case design. So we worked on test case design, right? We worked on the test cases. Then you have test execution and test log preparation. So we have also done that. Let's quickly check where we did it. Okay, so we have, we have written test cases. So this is what the test cases are. Okay, these are the test cases what we have written, and we have designed all things and executed. And as I told you, we have executed the test cases. So this is what we have executed it. We have put all those results. Okay, in this everything is good. Okay. All these are executed test cases. You see this, whenever you see this mark plus icon, these are executed one. Okay. So that is execution, and then it is log preparation. So log in sense, it's kind of attachment. What is the proof that you have done? It's kind of this log. Okay, you're preparing some log, or whatever the information stored in the rally. Okay, that's a log. Okay, so that's a log. Okay. Defect tracking. So of course, we have opened many defects. Okay, if you see this, a lot of defects. Okay, so once you open this defects, okay, you want to track it, right? You want to track it. So that's a number here given, D311, D310. Okay, and this is like whenever you want to go ahead and click on quality and click on defects, and you want to track here, you get all these things. So that's called defect tracking. Test report preparation. So here we also discussed about this reports. We have gone through this too. Okay, so we have completed our STLC process. So technically, we have completed all this STLC process, and this is burn down charts, all those things. So that's called STLC. Okay, test plan preparation, where we prepare our test plan, test strategy documents, all those things. Test case design, we have created test cases. Test execution, once you have created your test case, you need to execute your test case. So that's what you create: test execution and test log preparation. Then you have defect tracking. You want to track the defects, whatever defects you have created in this report preparation. So let's quickly check this. So this is what it says. We have done this. So here's the thing. So this is the hierarchy. If you are not sure, test engineer, what is its job? Test case design and daily reports. So that's the job of test engineer. That's QA analyst. Test lead. Who is the lead? What he'll be doing it? Prepare test plan, reviewing test case, defects, tracking reports. Okay. Okay. Test manager. What's his job? Manages the entire testing activity. Like they manage the whole team altogether. Okay. All team will be managing. So that's a test manager. So we have done this, okay. So yeah, this is the log, okay. So log in sense, okay, this is pretty much clear. Here we have log, right? Let's quickly check where we have this log. So once you open a defect, right? Let's go to the user story. Once you have this defects, right? Here, go to this. So this is a log, right? You see somebody has opened. This is not me. Okay, so here somebody has opened, right? This is a log. Okay, so all this information is showing up here. Okay, who has opened, and it's all this information. That's called log. Okay, is it failed? Is it passed? Okay, all those things. Okay, so we'll go through this. We have already talked about this defect status, always be in open, not in new. Okay, here when you open a defect, so here we are talking specific in one module. So this is the defect module. We have this, right? This is what we are talking about. So defect state: is it open, submitted, fixed, closed? Okay, so all these things. What is the defect status? We'll be talking in detail. So we have discussed about severity. We have discussed about priority. Okay. Okay. Any questions? So let's quickly check. So we have completed SDLC, STLC, and this is bug life cycle. So what's the bug life cycle? So it's bug life cycle is like when you open right from the new status, you want to, from the new status you want to change it from open, and from open. See, here's the thing. Okay, this is bug life cycle. Okay, once you open this defect, so this is what you can see it here, right? Let's see. So this is what we have done. We have done actually this. Okay, so here is the defect state. This is what we are talking about so far. This is the bug life cycle we are talking about. Okay, so let's quickly check here. So what is this? So once you open this new, change it to open status. Once you change it to open status, you want to assign it to someone. Assign to whom? Developer. Okay, developer, architect. Who is the person responsible for that issue, for the defect? Okay, we'll be assigning it. Once you assign it, there will be one more, like it's kind of, it's fixed. Okay, there will be one more, like fixed. Okay, so once it's fixed, that means it comes back to you. You want to test it. Okay, you want to test it, and once you verify, okay, it's good, verified and closed. This is a normal cycle. Okay, this is, you go one flow: new, opens, assign, test, verified, closed. Good. Now this is not always easy. Okay, this doesn't happen that way. So what happens, right? Once you give the test, you say, no, this is not fixed. Why? Because it's again showing up. You reopen again the defect. Again, you assign it. So it's not my job. He assigns to some other guy. Okay. Now it assign it and again test it again. So this cycle flows. Okay. Let's say it's not even that. It's pretty complicated. So once you go to new, open and assign, now developer rejects it. Okay, they can reject it because why reject? Because it's there is no. So that's the that's the reason, right? I asked you, like, if you have 5 to 10 minutes. Okay, so we are almost done. Okay. Okay, so reject. We reject it. They might reject it because it might not be issue. It might be a feature. Okay, so that's about the reject, and it might be deferred too. Deferred in sense, it might be, they might put it into different release. Okay, they will be putting into different release. Okay, so that's why it goes into, because they might not have time. They might not have enough to so that's why it gets deferred. So that's why this is deferred. Yeah, I know. Like, that's the reason I asked you guys to if you are okay, 5 to 10 minutes. Nobody responded, so I thought everyone is okay. Okay, it's okay. You will be having this recording. Okay. Any questions? Any questions so far? So that's about bug life cycle. So if no one has any questions, can we close this class for today? Okay, thank you guys.